And we design our infrastructure like an urban rail system to fit that bell-shaped curve. But if you change that average, and we've changed it 1 degree Celsius across Australia already, and we're headed rapidly toward 2. If you change that, that's what it looks like. This bell-shaped curve gives you a disproportionate effect so that hot days become far more frequent, days above 35 degrees Celsius. And really extremely hot days, which you didn't see before, now become common. And here's the classic example. There's Melbourne. There's their public transport system, February 2009, when they hit 46 degrees, which was well above anything they'd experienced since records were kept. So the point we want to make here is the climate shifts we're seeing is taking us beyond the envelope of climate in which we live, in which we've designed our infrastructure, in which our plants and animals have evolved. So this presents very large challenges for us as we go into the future. And with that, I'm going to let my colleague Leslie Hughes tell you much more specifically about what's happening to the Illawarra region. I have to make a comment about the St. George football team because I'm from Canberra, of course, and if any of you saw the results from last night.
Will actually wanted me to replace the St. George bit with whatever team plays in Canberra, but Raiders, thank you. Thank you, everybody. I've been studying the potential and observed impacts of climate change on ecosystems for about the last 20 years. If climate change wasn't actually having any impacts or predicted to have any impacts, it would just be the purview of people like Will in their laboratories fiddling around with their computer models. But we should care about climate change because of the impacts that it will have on all of us. Okay, firstly, temperature. As Will said, temperatures have increased by about 1 degree across Australia over the last century or so. In this particular region, in the temperate regions of southern New South Wales, we've had the increase of 1 degree since about the 1950s. All of us that live on the east coast have been painfully aware of the long-term drying trend that we've had, notwithstanding the hideous weather of the last weekend if you live in these regions. We've had a long-term drying trend over at least the last 40 years. In the future, we don't know what will happen to rainfall. The models, some of the models predict increases in rainfall, some predict decreases in rainfall. Rainfall is very, very difficult to predict with any degree of certainty. The best thing that we can say is that we need to be prepared for every eventuality. What we have seen over the last 20 to 30 years, however, is an increase in extreme fire weather in the South Coast region. Fire weather is modelled using an index called the Forest Fire Danger Index, and on the South Coast this has increased by between 10 and 40% depending on the region since the 1980s. In the Nowra region, for example, it's increased by 30%. The models indicate that we're looking at least another 20% increase in the Forest Fire Danger Index over the next few decades. So what this means is an increase in the probability of not only more frequent fires, but far more intensive fires. We have had about a 20 centimetre sea level rise since pre-industrial times. This varies depending on where you are around the coastline. We're looking at predictions of between a 50 centimetre and 1.1 metre further increase in sea level rise by the end of this century. Now, to put that in perspective, a 50 centimetre sea level rise means that a coastal flooding event that currently happens about once every 100 years could happen once every few months. This region has a lot of coastal infrastructure and rail and road very close to the coast. The modelling in the report that we present today indicates that in the Shellharbour local government region, for example, there are between 100 and 150 light industrial buildings at increased risk with a 1 metre sea level rise. Sea level, of course, also has impacts on ecosystems. We're seeing in northern New South Wales, for example, severe cases already of coastal erosion, people sandbagging their houses against storm surges and flooding. In general, even though we can't predict with any degree of confidence exact changes in rainfall. What we can say with a reasonable degree of certainty is that when we get rainfall, it will come in more intense bursts, and when that happens, there's an increased risk of flooding. And this is what I work on and have been for some time, the impacts on ecosystems. Ecosystems and biodiversity are our life support system. It's not just a matter of them being cute to look at and us liking the fact that they're around. Species provide our food, our fibre, they filter our water, they decompose our waste. Humans wouldn't be here without the wealth of ecosystems that we depend on. In this particular region, there are over 100 listed threatened species. That's listed under New South Wales legislation. About 70 of those are animals and about 30 are plants. There are also a number of endangered listed communities. These are the sorts of species that we're most worried about in future because they are already stressed. They already tend to have small population sizes and narrow ranges. They will be at direct risk from changes in climate that are occurring too rapidly for them to be able to keep up simply by evolving or by moving somewhere else. Things like increases in fire as well will have indirect but very severe consequences for much of our biodiversity. We've called our report the critical decade, and this is really the reason why. What this graph shows here is firstly the temperature along that bottom wiggly line is the temperature that we've had so far. So this is where we are now. And what this graph shows is two potential ranges of our future. The blue bands are our future in terms of temperature if we manage fairly significant greenhouse gas abatement and keep temperature increases compared to pre-industrial at 2 degrees or less. The red bands indicate the range of business as usual scenarios, and as you can see, it's a pretty frightening increase. Now, a lot of people find these sorts of graphs pretty hard to relate to at a personal level, so I'd like to try and make this a bit more personal. I was born in the 1960s, so there's my lifespan, presuming that I live to a sort of an average age of about 85. And I've drawn that bar at the average global temperature that I will experience over my lifetime. I've got 2 teenage kids born in the 1990s, and assuming that they live about the same length of time, I've drawn their lifespan at the average temperature that they will experience under a business as usual scenario over their lifetime. Now, if I ever have grandchildren, assuming my kids have kids when they're about 30 and they live about the same length of time, I've drawn that bar at the temperature at which my grandchildren might experience over their lifetime. What we really have to do is pull those bars down and keep them down there in order to have a habitable planet. And that's what the Climate Commission is all about. With that, I'm going to hand over to my colleague, Jerry Houston.